Hello, so in this video we're going to talk through some differentiation questions together. Now, just a heads up, I'm going to assume that you have met differentiation before. So if you haven't, I recommend that you go away and watch the introductory videos on my channel. There's plenty of them out there, which will fully introduce differentiation to you if you've never met it before. Alternatively, there are some lecture notes available on the VLE site, which you can just kind of read through, and that's also an introductory to differentiation as well. But this video is going to be more about doing some questions and getting hands-on with actually differentiating stuff, and then hopefully, you know, you'll be a little bit clearer at the end of the video about how to answer questions to do with differentiation. So first things first, let's have a look at this question on the screen. I've been given a polynomial, so y equals 3x to the power 4 plus 5x cubed minus 8x squared minus 4x plus 7, and I've been asked to differentiate this function with respect to x. So just remember, differentiation is all to do with rate of change. It's simply saying, as x changes, how quickly does y change as well? So it's rate of change, okay? Now another way of saying that is gradient or dealing with tangents. So in other words, I need to differentiate this. So just remember, to differentiate, I'm going to write this as dy by dx, okay? I need to bring the power down, so in this case, I'll just deal with it term by term. Bring the power down, I get 3 times 4, which is 12. Then I reduce the power by 1, so the 4 becomes 3. Okay, and I just do that for every single term. So looking at the next term, I get positive. 3 climbs down, so it's 3 times 5. And I reduce the power by 1, so it becomes 15x squared. The next one, I look at 8x squared, so bring the power down, it becomes negative 16, and then I reduce the power by 1, it becomes x to the power of 1, or just x. If I look at the next one, you're looking at that and going, there's no power of x on there. Well, there is, it's just it's hiding, it's x to the power of 1. So if I bring the power down, I get negative 4 times 1, which is negative 4, and then I get x to the power of 0, okay? And then finally, if I look at the last term, well, there's no power of x written there, but there is a power of x, it's just that power is 0, because of course x to the power of 0 is just 1, okay? So if I bring the power down, it becomes 7 times 0, which is just 0, okay? Then I reduce the power by 1, becomes x to the power of negative 1. So tidying this up slightly, 12x cubed I can't do anything with, 15x squared can't do anything with, negative 16x can't do anything with. The negative 4x to the power 0, x to the power of 0 is 1, so it's negative 4 times 1, which is negative 4. And then 0 times anything is still 0. So in other words, what I'm saying is that differentiating this function with respect to x, I get this function here, okay? Now this is my gradient function. Notice it's still got x's in, okay? The reason being is because now I'm in a position, if I take it back to what I got given originally, I'm in a position where if you ask me now, find me the gradient at the point x equals 1. Okay, then all I have to do is use this newfound gradient function, this dy by dx, or gradient function, and if I stick x equals 1 in here, I'll be able to find the value of the gradient. So let's do this, okay? So at the point x equals 1, I find that my gradient, so dy by dx, okay, change in y divided by change in x, should be 12 times by 1 cubed, because I'm just literally sticking 1 in here, plus 15 times 1 squared, minus 16 times 1, minus 4. Okay, so when I sit down and I calculate that out, I get 12 plus 15, that's 27. Take away 16, that's 11, and then take away another 4, that comes out 7. So what that literally means is that if I look at this curve here, the y equals 3x to the power 4 plus 5x cubed minus 8x squared minus 4x plus 7, and I want to find the gradient of the tangent, okay, I want to find the gradient of the curve at the point x equals 1, it is going to be 7, okay? Let's have a look at another one, so a slightly more complicated one. Let's have a look at this function. So if we have f of x is equal to the cube root of x to the power 4 plus 5x to the power of 9, all divided by the square root of x, all cubed, okay? Now, if I want to find the gradient function of this, then first of all, I'm going to have to do a little bit of rewriting. So I'm going to have to make use of my laws of indices. So first things first, I can't differentiate this because it's not written as terms with like a coefficient and then the x to the power of something. It's got cube roots in and I've got fractions and stuff going on, okay? But that's fine because I can use my laws of indices to deal with this, okay? So I can say that first of all, I have the cube root of x to the power of 4, Okay, so let's have a look at the cube root of x to the power 4. Well, that's just simply x to the power of 4 over 3. You remember that when I have roots, it's basically can write that as a fraction where the denominator of the fraction is whatever root I'm taking, the nth root. Okay. Now I've got then 5x to the power of 9, so I'm going to leave that alone, so plus 5x to the power of 9, okay? And then I'm going to divide that by the square root of x cubed. Now again, I can write that as x to the power of a half, all cubed. If I do a little bit of tidying up, I'm actually just going to do it down here, multiply the fractions together, I get 3 over 2, okay? So that's on the denominator. Now all I need to do is basically separate this up. So this term gets divided by x to the power of 3 over 2, and this term gets divided by x to the power of 3 over 2. So in other words, I get x to the power of 4 over 3 over x to the power of 3 over 2, plus 5x to the power of 9 divided by x to the power of 3 over 2. Okay, and then I just simply have to subtract those powers now to make sure that I have x to the power of something. So let's see, x to the power of 4 over 3 divided by x to the power of 3 over 2. When I subtract those powers, 4/3 minus 3 over 2, that comes out as negative 1/6. So I get x to the power of negative 1/6 on the first term. And then the second term, when I'm going to get 5, and then I have to do x to the power of 9 divided by x to the power of 3 over 2. I just need to subtract the 9 and the 3 over 2. So 9, take away 3 over 2, comes out as it comes out as 15 over 2. So x to the power of 15 over 2. Okay. So now what I've got is a function which is written in the form some number times x to the power of something. So these things are exactly the same. So this thing, they're exactly the same. The only difference is that I have it written as some number times x to the power of something. That means that I'm able to differentiate it. So if I differentiate it, I'm just going to use slightly different notation because I'm using f of x. So if I differentiate it, I'm going to write it as f prime of x. Okay, it means differentiate rather than dy by dx all the time. Okay. So what I'm going to do is bring the power down and then reduce the power by 1. So 1 times by negative 1/6, that's negative 1/6 times x to the power of, well, if I have negative 1 over 6 and I take away 1, that becomes negative 7 over 6. Okay. And then finally, I end up with, on the second term, 5 times by 15 over 2. Well, that comes out as 75 over 2. Then if I reduce the power by 1, I get x to the power of 15 over 2, subtract 1, that comes out as 13 over 2. That's the power of the x at least. Now you could, if you wanted to, leave it like this. But it's always good practice to make sure that you leave whatever you've got here in the same form that you were given it in. So you notice that we were given it with like roots and fractions and stuff like that. So there were no negative powers and no fractions in the powers. So I'm just going to rewrite it, okay? So look at this. If I just scroll up so we're focused on this. Have a look at x to the power of negative 7 over 6. Well, the negative just means 1 over. It just means the reciprocal. So I get negative 1 over 6 times by 1 over x to the power of 7 over 6. Then if I look at the second term, I get plus 75 over 2 times by x to the power of 13 over 2. Well, are you happy that denominator, so that's root, becomes the square root of x to the power of 13. That denominator of the fraction, the 2 there, climbs down to become the second root. But of course, we don't write the second root, we write it as square root instead. Okay. Now just one final little thing to tidy up. The x to the power of 7 over 6, again, I can rewrite this, so I get negative 1 over 6 times by 1 over the 6th root of x to the power of 7. Again, that denominator of the power, the fraction in the power, climbs down to become the root. Then plus, and I'm going to write this as 75 root of x to the power of 13, all divided by 2. And again, I'm just going to multiply these two fractions together. So I get negative 1 over 6 6th root of x to the power of 7 plus 75 root of x to the power of 13, all divided by 2. And that's how I'm going to leave my answer, okay? I'm not going to simplify it anymore and try and combine it to one fraction. I think this is enough. We've done the task of making sure that we're leaving it in the same form that we were given it in, so with roots and stuff, okay? Rather than as fractional powers and negative powers.